Assalamualaikum warahmatullahi wabarakatuh. In this occasion, we will present about simple linear regression and correlation. Before that, let us introduce ourselves to you. First, me, Salsabila Khairunnisa. Second, Fauzal Syukri Rahman. Third, Fahdhila. And fourth, Yaain. There are 7 topics will be present in this occasion. The first and second topic will be present by me, Salsabila Khairunnisa. They are Introduction to Simple Linear Regression and the Method of Least Square. The third and fourth topic will be presented by Fauzal. They are Properties of the Least Square and Estimators of Variance. The fifth and the sixth topic will be presented by Fahdhila. They are Assessing the Utility of the Model and the Coefficient of Correlation and Determination. And the last topic will be presented by Yaain. It is using the model for estimation and prediction. First topic, Introduction to Simple Linear Regression. Before we discuss more about simple linear regression, we should know about the definition of regression. So what is the regression? Regression is a technique for determining the statistical relationship between two or more variables where a change in dependent variable is associated with and depends on a change in one or more independent variables. Next is regression analysis. Regression analysis is the collection of statistical tools that are used to model and explore relationships between variables that are related in a non-deterministic manner. There are 2 types of regression analysis. The first one is simple regression analysis. Simple regression analysis is the relationship between 2 variables, namely the independent variable and dependent variable. Second is multiple regression analysis. Multiple regression analysis is the relationship between 3 or more variables, namely at least 2 independent variables with 1 dependent variable. So, what is independent variables and dependent variables? Independent variables are regarded as inputs to a system and may take differently value fairly in a system. Independent variables are denoted by X. Independent variable also called as regressor, predictor, or explanatory variable. Second, dependent variable. Dependent variable are those values that change as consequence of change of other value in a system. Dependent variables are denoted by Y. Dependent variable also called as response variable. Historical of regression analysis. The person who first discovered the term regression analysis is Sir Francisco Galton in a study of the head of father denoted by X and sons denoted by Y, and him fit a least square line and use it to predict the son's head from father's head. He found that if a father's head was, a similar effect was observed for below average heads. That is, the son's head regressed toward the average. Consequently, Galton referred to the least square line as regression line. Next, we will discuss about simple linear regression. Simple linear regression. There are 3 characteristics of simple linear regression. The first one is only one independent variable denoted by X. Second, relationship between X and Y is described by a linear function. And third, change in Y are assumed to be caused by changes in X. Next is types of relationships. There are 5 types of relationship between X and Y. The first is linear relationship. This is curve of linear relationship. The first curve is positive linear and the second curve is negative linear. And this is the curve of curvilinear relationship, and this curve of strong relationship, and this the curve of weak relationship, and last is the curve of no relationship. Strong relationship happens when the absolute of the correlation coefficient, or R, is between 0.8 and 1, and the weak relationship happens when the absolute of the correlation coefficient between 0 and 0.5. Meanwhile, no relationship happens when the correlation coefficient, or R, less than 0 or bigger than 1. Next, simple linear regression model. This is a simple linear regression model. Y equal beta 0 plus beta 1 multiply x plus normal random variable or error term. There are two variables in this equation. First, x equal independent variable, y is dependent variable. And there are three parameters in this question. First is beta 0. Beta 0 is intercept. The y-intercept of a line is the point at which the line crosses the y-axis. Second is beta 1. Beta 1 is slope, change in the mean of y for unit change in x. And last is normal random variable. And this is a curve of simple linear regression model. As you can see, there is a straight line that goes up. This line. This line is a line of y equal beta 0 plus beta 1 multiplied with x plus normal random variable. And this is run and this is rise. So if you want to find beta 1 or slope, you can divide the value of rise with run. And this is the beta 0 or y-intercept of a line is the point at which the line crosses the y-axis. The second topic is the method of least square. Residual error in fit. A residual is essentially an error in the fit of the model. As you can see here, there are three formulas here. The first formula is the predicted y value. It is denoted by y hat. Y hat equal with b0 or beta 0 plus b1 or beta 1 multiplied with x. And the second formula is residual error. Residual error equal with y minus y hat. Y is the observed y value and y hat is the predicted of y value. When I equal with 1, 2 until end. And the last formula is the equation for simple linear regression. Next is the method of least square. As you can see, there are some formula here. The first formula is SSE, or the sum of squares of the errors, or the sum of square of y minus b0 or beta 0 minus b1 or beta 1 multiplied with x. Differentiating SSE with respect to b0 or beta 0 and b1 or beta 1, we have the formula like this. And the last formula is the sum of y and the sum of x multiplied with y. Next is estimating the regression coefficients. There are two estimating the regression coefficients. The first one is b0 or beta 0 and b1 or beta 1. And this is the formula for b0 or beta 0 and b1 or beta 1. the value of B1 and B0, it's needed for the equation of simple linear regression. So if you want to get the equation of simple linear regression, you should find this value, B0 and B1. Okay, I think that's all from me, and the next slide will be presented by Fauzal. Thank you.
My name is Fauzal Syukri Rahman. We go to the next topic. The next topic is properties of the least square estimator. In this slide, we can see we have the formulation for mean and the formulation for sigma square, or we can call it the variance. This formulation using the general variable. We go to the next slide. We can see we can construct the sigma square or the S square with the SSE value, and we can construct the SSE value with the total variability like S double X, S double Y, and the SXY. That value have its own formulation from the general variable that we can get for our data. So we can substituting that value to find the SSE value, and we go to the formulation for sigma square. We use the SSE value to the formula to get the value of sigma square. We can also using this formulation for find the value of S square, and this formulation we call it with the mean square error. We go to the next topic is estimator of variance. We can see in this slide we have a SSE formulation, and we can substituting that value to this formula, and we get the other formulation for SSE. And the value of SSE, we can using that value for construct the estimator of variance, like we can see in this formulation.
My name is Fahdhila, and today I'm gonna presentate about assessing the utility of the model. Actually, there are 3 points that I will present it today to you. The first is assessing the utility of the model, and then the second is about coefficient of correlation, and then the last is about coefficient of determinant. So the first thing is assessing the utility of the model. So in assessing the utility of the model of linear regression model, we use the hypothesis testing. So here I put F-test method, and the first thing that we have to do is determine the hypothesis. So there is hypothesis 0 and then hypothesis 1 or hypothesis A. After we got the hypothesis, after we determine the hypothesis, so we make a NOVA formula. There are SST And SST actually divided into two components. The first is SSE without variation, noun, and then SSR with variation, that noun in linear model. So next, this is the formula of F-task. You can see from the table. So if we want to calculate the F-task, first we have to calculate the MSR and then MSE. After that, we divide MSR with MSE. So we will get the F-task value. And this is the rejection region of F. So next, and this is the F-task for subsets of independent variables. There are full model and then reduced model. And this is the formula of F-task. There are SSER and SSEF. SSER is error sum of square for reduced model with L predictors. And then SSEE is error sum of squares for full model with K predictors. And then next topic is about coefficient of correlation and determination. Coefficient of correlation. Actually, in linear regression, X is a mathematical variable and Y is a random variable. It is usually assumed that the observation xi, yi, where I is 1, 2 until n, are jointly distributed random variables obtained from the distribution f x, y. And mu y is the mean of y, and then sigma y square is the variance of y. That also mu x is the mean of x, and then sigma x square is the variance of x. And this is the symbol of correlation coefficient. And then this is the formula. You can see the formula. So if we want to calculate the coefficient of correlation, we can use the formula that I put here. Then next is coefficient of determination. So actually the symbol of coefficient of determination is R square usually, and then the formula is 1 minus SSE over SST. And here I have put the formula of SSE and SST. So if we want to calculate the coefficient of determination, we just need to calculate the SSE and SST. After that, we can use this formula to calculate the coefficient of determination. Okay, maybe just it for me. Thank you very much.
Okay, everybody, with me Muhammad Yaain. Now we're gonna talk about using the model for estimation and prediction. For the estimation of a simple linear regression relationship involves finding estimated or predicted value of the intercept and slope of linear regression line. And the estimated regression equation you can see in this slide, where beta 0 estimates the intercept, beta 1 is the slope, E stands for the observed errors. And the estimated regression line, you can see y equal beta 0 plus beta 1 multiply x. And the estimation, we need to find sum of squares and cross products first. Sum of squares x, y, and cross product x and y. And for the least squares regression estimators, you can see in this slide beta 1 and beta 0. Okay, for the example of estimation, from the data at the left side, you can see that miles and dollars. X is miles and Y is dollars. So we want to know, is there any relationship between miles and dollars, and we can use the simple linear regression to prove it. If there any relation of, is there any relationship or not? Okay, from the formula, and we got the beta 1 and beta 0, the intercept and the slope and the intercept. Next, prediction. First is point prediction. Point prediction is a single value estimate of y for a given value of x, obtained by inserting the value of x in the estimated regression equation. And prediction interval, there's two kind. First is for a value of y given a value of x, and for an average value of y given a value of x. Prediction interval for e y given by x, the prediction band for e y given by x is narrowest at the mean value of x. The prediction band widens as the distance from the mean of x increases, and the predictions become very unreliable when we extrapolate beyond the range of the sample itself. For the example, prediction interval for a value of y, you can see the formula, and we use the x equal to 4,000, so it means 4,000 miles, and doing the calculation, and we got in prediction interval for a value of y is between 4,619 and 5,972.67. And the other one, prediction interval for the average value of y, you can see also the formula in the slide. We use also the x equals 4,000, and we got the prediction interval is between 5,139.57 and 5,452.53. Okay guys, that's all what I can share to you. Thank you for watching. I'm sorry if I have wrong when share this. Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh.